Yes, ma'am.
So the same analogy here as well, where we consider this is my older value. Sorry, this is my new value. The current door, the key that I've lost, I'm just going to press it out with respect to, it is going to check out, okay, how many of the other values that it has already tried, okay, the H value, the previous H values, okay. So it is taking the estimated value of the probability of with respect to the new one, with respect to the old, with all the training instances that it has gone taken up. This has been my estimation step, okay. My maximization step is what is the argmax of the values whatever I've tried. With all of these 100 keys that I'm going to press out, what is the maximum value that I get out of these value? That will be my maximization step that I will apply onto that EM model. You're getting the 100 probabilities that I'm going to check, right? With all of those 100 probabilities, it will come up with a maximum value. That maximum value is what it will take it and it will apply it to it. It will come to a convergence, take the maximum likelihood hypothesis of that and see the mean square error is less. If not, again, it will perform all of its operations to check out that the final thing is wherever you have these missing data values, it will come up with respect to whatever the mixture model data it has, whatever the input values it has, according to that, it will try to fit that missing value with some other value based on the learning of it. Based on the learning of the system, whatever the value that is missed out, okay, it will try to come up with a new value that actually fits to the solution. So that estimation step is identifying that value, identifying the probability of the value fitting to that, okay. Second one is the maximum value of it is what I'll be applying onto it. Come to a convergence to see, okay, whether whatever I've applied onto this, right, the maximum value that whatever I've put onto this is coming out to a solution or not, whether I get a maximum likelihood hypothesis for that. If so, I'll stop the solution. If not, again I'll be repeating the steps to perform this model. This is about your EM algorithm, okay. And there's a derivation, as I told, K means identifying the mean values. Here you have to identify the mean values. Why do you need to identify? Because when I have a mixture model of it, okay, I need to get to know the mean and the standard only when I get to know the mean and standard deviation of this mixture model, I can place them into the respective buckets, that is clusters. I can cluster them into two different things. When I don't know that particular mean and standard deviation of it, it is very difficult for me to get it. This is how your k-means algorithm will also work. It will have a mixture of data that is given to you, the values to you. You have to come up with two separate buckets. You have to classify them separately into two different categories by clustering them. You're going to cluster them. How do you cluster? You really need to calculate the mean and the standard deviation of that, and you need to calculate a point where all the closest value of it will form a cluster, or the other closest form of it will form the other cluster. It will identify the distances between them. What does that distances mean? I have one data point. From the other data point, I'm going to calculate the distances between the others, which is nothing but standard deviation. When I have a bell curve, I have a mean value given to it. From the mean to the difference is basically your standard deviation. So upon that is what it will try to cluster them into two different groups. An example, same analogy with respect to your k-means. But in k-means, the exact cluster points it will give you, in the sense it falls into this category, it will go ahead. Whereas EM algorithm, it will have overlapping values also. It's a soft clustering, it is not a hard clustering, it is a soft clustering. Whereas your k-means is a hard clustering, where it clusters separately into two different clusters. Like it will place a data point directly into one of the other. It will not be overlapping together. But in EM, there are certain overlapping algorithms that come under. That's why I've written over here, refer k-mean algorithm derivation from the feedback, sorry, from the textbook, okay. So which is nothing but basically k-means is also a similar derivation. From here we actually derive it. We've already seen the same derivation with respect to gradient descent, okay. We have done for that the maximum likelihood hypothesis. A similar derivation is again applied onto it. It's there in your text. I want you to trace it, so that whatever we have derived earlier, I want you to recall it and again trace this, okay. That's why I have not specified over here. Please refer to your textbook. We have already done each and every step in that. If you have any queries, you can get back to me on it. But I want you to trace the derivation. Okay? Is there any doubts in this EM algorithm? just think of an example with respect to you have lost your bike key, okay, and you're trying to fit a key into that, and you have your classmates of 100 keys with you. You're trying to see, okay, with those 100 keys, is my bike today, can it open or not? Okay, fine. If there's anything, you can let me know.